All right, so we're gonna start here. Well, you should have completed your do now. Just making sure that you didn't have too many issues with the do now with the assignment. I just want to highlight a couple of things really quick. The matching should have gone fairly easy. The challenge was that maybe you didn't use your notes and how to match it. At the bottom, with the remaining range, it's okay if you did not use all these on one. So like the y the only thing that applies to y is the domain and range are both from negative to infinity, right? So that would be the D. On y equals x squared, nothing applies to that, right? It has symmetry, it has intercept. Remember, zeros is another word for x-intercept. That's from algebra 1. And the domain and range does not go from 0 to infinity, just the range. So therefore, this line was left blank. On C, the constant function, the domain and range isn't from negative to infinity. It has no zeros, is the only one that applies. And then y equals the square root of x. Well, the y equals square root of x. Domain and range are 0 to infinity, and it has no symmetry. So it should have been A and C. Okay. So I just wanted to go over that little piece with y'all before we jump in. All right, so we're starting our second day of parent function attributes. We are focusing on absolute value, rational, cube root, and cubic and cube root functions. We're going to start with the absolute value function. You should have seen this one before. Absolute value is f of x equals the absolute value of x. In some calculators, you may see it as abs. Okay. The absolute value is made up of two linear equations, an increasing and a decreasing. Do we see that? Okay. Key points for absolute value. You have that it's at the origin. And the whole purpose of absolute value is distance. Absolute value means how far are you from 0. So notice that there are only positive y values. We have 1, 1. We have negative 1, 1. And that's because how far is the x from 0 is what you're asking. How far is negative 1 from 0? Well, it's only 1 unit away. Domain. So the domain here is all real numbers. So we go from negative infinity to positive infinity. My range has a starting. I start at 0 and I go to infinity. So range is y is greater than or equal to 0. My x and my y-intercept is both at the origin, right? So we're both at the origin. And asymptote, there's no imaginary boundary line preventing me from being great, okay? There's no imaginary boundary line preventing me from being great. Maximum. The maximum does not exist. But I do have a minimum. My minimum is located at x equals 0. And what type of symmetry do you see? Reflectional. I'm evenly divided by the y-axis. Okay? Inverse function. It does not have an inverse function. All right, how do you feel about absolute value? Do you feel comfortable and understand the attributes of it? Okay. Next, we have our rational. Okay. Our rational function. It's also sometimes called a reciprocal function. So if you ever hear a teacher or someone. So rational, f of x equals 1 over x. Okay? The rational function is, it has critical points at negative 1, 1, and negative 1, and at 1, 1. It actually is our first function with asymptotes. It has a vertical asymptote at x equals 0. I didn't mean to write y. at x equals 0, and it has a horizontal asymptote at y equals 0. Okay? This is important for the domain because our domain is split, right? We have two functions happen. So if you remember from your interval assignment, how your line, you had two lines heading different ways. They were disjointed. Our graph is disjointed. Do we see that? And so remember how on your assignment you were using the word or? So in place of the word or, we use the union symbol. Okay? So in formal notation writing, instead of using the word or in our interval notation, we're going to use the union symbol. So my domain, starting from the left, I go from negative infinity and I get as close as I can to 0, but do I ever touch 0? No. So my domain is from negative infinity to 0, parentheses, because I'm not touching 0 because of that asymptote. Union. So then I continue and I go from 0 to positive infinity. How do we feel? Okay? So our range is doing the same thing, right? We're going from bottom to top. So from the bottom, I'm going from negative infinity and I'm going up to 0. However, because of that asymptote, I can't do anything. So my range is the same way. Okay, I'm going to write this in set notation at the top so that you can see the formal way of writing this. So if I was to write this in set notation, my braces, x, such that x is in all real numbers, but x does not equal 0. That's how it would look in set notation. So x, the domain, such that x values exist in rational numbers, but x does not equal 0 is the set notation. And in the case of y, instead of x, it would be a y. Okay? Our x-intercept and y-intercept do not exist because of the asymptotes. And our asymptotes are at y equals 0 and x equals 0. Y equals 0 is our horizontal asymptote, and x equals 0 is our vertical asymptote. Okay? There's no maximum, no minimum. It actually has rotational symmetry. Since the asymptotes are part of my function, they go through the origin, and if I was to rotate my paper 180 degrees, does the shape of my function change? Okay? Inverse function. There is no inverse. Well, this is also. However, make a note that it is the reciprocal of f of x equals x, aka your linear. It's its reciprocal function. Oh, sorry. Remember, reciprocal with a fraction means that you are literally switching the place of your numerator and denominator. Questions about reciprocal? Okay. Finally got to use our asymptotes. Yeah. All right. Cubic and cube root are gonna go fairly fast. So we have f of x equals x cubed. Our critical points are 0, 0. And we're going to use 1, 1, and 2, 8. The key thing about cubic function is that they are the points have their opposites. So if I have 1, 1, then I'm going to have -1, -1. If I have 2, 8, I'm going to have -2, -8. So if you look on your graph, you'll see that I have -1, 1, and I have -2, -8. Okay, the domain and the range. This graph goes on forever. So the domain and range of this graph are from -infinity to +infinity. The graph crosses through the origin. So therefore, its x and y intercept are 0, 0. There is nothing preventing it from being great. There is no maximum. There is no minimum. And what type of symmetry do I have? Rotational. Good job. Okay. It's inverse function. So it's f equals the cubic root. The opposite of cubing something is to take its root, the cube root. Ouch! Hit my elbow. All right. Our last one, cube root function. So we have f of x equals the cube root of x. And just like its friend, the cube root, it goes through the origin. Our critical point now is at 1, 1. Our next critical point isn't until 9, and it's not on the graph, so all we can focus on is 1. Okay? The domain and the range, the function goes on forever. -infinity, +infinity. Range, -infinity, +infinity. X-intercept, I go through the origin, so therefore my x and y-intercept are 0, 0. I have absolutely nothing preventing me from being great. My asymptotes do not exist. I have no maximum. I have no minimum. And what type of symmetry? Rotational. And my inverse function is called the cubic function. Okay, that is cube root. Questions about cube root? Do you feel comfortable with the attributes? Can I get a head nod? Okay, I was gonna get something. All right. So on number 1, y-axis symmetry. So it should have been I. I'm trying to write an I. There we go. Number 2, you should have got an O. I'm making an O. I think my board is mad at me. Uh-oh. I hope it's O come up at some point. On number 3, you should have gotten V, the graph with the maximum value of 3. On 4, you should have gotten F. It has a y-intercept. Oh my goodness. Oh no. That's an S. On 5, you should have gotten D. The graph with the domain from 0 to infinity. On 6, you should have gotten N. That's N. It's just, I don't know what's going on with my board. Goodness gracious. Okay. So here, I didn't realize that the sentence got merged together, but it should be he wears glasses during math because it improves improves division. Not, you get it? Improves division. You get it? It improves division. Yeah. Okay. All right. Don't get it. It's okay. So classwork. We took a little longer, but the last part of class, you're working on this. The classwork to complete and insert answers in Canvas assignment. So you have the paper, and you're going to insert the answers into the Canvas assignment. And that's it. We made it.